Question 2, we've got a speed time graph, very standard, constant acceleration up to a speed where then that's maintained between 4 and 18 seconds, and then a constant deceleration. The trick with these questions is that the area under the graph, being a speed time graph, will be the distance, and we're told that the distance is 200 meters. So you sort of need to just store that fact up and work on it later. All of these facts are in the diagram, so we can go straight into part A. And we're asked to find the acceleration of the athlete in the first 4 seconds of the race. Now, the acceleration is simply the gradient of this slope. The rise being 10, the run being 4, literally a run. So the acceleration is equal to the rise, which is 10 over 4, the run, and cancelling this down, 5 over 2 meters per second squared, or ms to the minus 2. Part B, we're asked to find the distance covered by the athlete during the first 18 seconds of the race. That's up to this point here. So I'm going to call this area 1 and this area 2. And if I add those two areas up, I will get the distance that the question requires. So first of all, area 1, it's the area of a triangle, half the base times the height. So this is a half multiplied by 4 multiplied by 10. And that is equal to 20. The second distance is the area of the rectangle here. Height 10, 18 minus 4 is 14. So this is 14 multiplied by 10. So this is equal to 140. The total distance is equal to 20 plus 140, which is 160 meters. And that's the answer to part B. And in part C, we've been asked to find the value of u, which is the speed at which the athlete passes the finish line, 24 seconds after the start. Well, to do that, we need to find the area of the third section of the journey. Now, this area is a trapezium. So it's the average of the parallel sides multiplied by the distance between them. The distance between them is 6. And one parallel side we know to be 10, the other parallel side is u. So the average of 10 and u is 10 plus u, both divided by 2, multiplied by the distance between them, 6. So this simplifies to 3 multiplied by 10 plus u. Well, we've calculated the distance of the first 2 sections of the race, and as we're told, the total race is 200 meters long. This must be equal to 40 meters. And if you work that out, you get a value of u to be 10 over 3. And this is meters per second. And that's the answer to part C.